everybody to do is I want everybody on the count of 3 to say, "Hey, Joseph Moss." 1, 2, 3.
Hey, Joseph Moss.
Joseph and his family's at Disney World this week.
Lucky.
Ah, no.
Joseph.
I know. So, I'm sure he'll look online, so I'm going to give him a shout out. Trent, close my door over there. So if you're really OCD about stuff, this starts the second 9 weeks. We have 27 weeks left. Gina, I hope you're writing notes up there and not notes. Second, it's the whistle. Second 9 weeks, we got 27 weeks left of school, and you will be high school students. This week, what I'm going to do is I'm going to front load the class. Okay? I'm going to teach everything in about 2 days. You're going to have several assignments, and they're already up online. They're due on Thursday. Everything's due Thursday. Like Wednesday, Thursday, you may have the entire class to work on stuff. I wouldn't save myself. Like your weekly, it's already online. It's due Thursday. Okay? 20-some questions, but most of them's multiple choice. I don't think you'll have a problem. Okay? This section of math that we do, this is total 8th grade. No math 1 stuff this week. This is total 8th grade. This is called the number system. We're going to be talking about numbers, breaking numbers down, and then it's going to kind of be like a math lab. You're going to go at your own pace, but it's got to be due Thursday. So if you want to knock it all out by Wednesday, I don't care. You know what I'm saying? Friday, you will have an in-class assignment, kind of like a quiz, but not really like a quiz type thing. They'll just kind of review back over the week. Okay? So, it's we're kind of see how this works. Work at your own pace type thing. Just kind of change something up a little bit. So if you want to knock everything out, you can. Have to coast the end of the week. It's up to you. Okay? Number systems. Number systems, we look at numbers and we give them little categories. We put them in categories. And the big thing in 8th grade is rational, irrational. I think that fits because either you guys are rational or you're irrational. Everything is so important and dramatic in your life or you're having a good day. Okay? There's usually not middle ground. So we got rational numbers, we got irrational numbers. A rational number is a fraction. Any fraction. I don't care what type of fraction. I don't care if it's a perfectly reduced fraction. I don't care if it's an improper fraction. I don't care if it's a mixed number. If it has a fraction bar in it, it's a rational number. Whole numbers. Any whole numbers. No matter what the whole number is. Doesn't matter if it's negative. It's fine. It's still rational. Okay? Fractions. Whole numbers. It's okay if they're negative. That's okay. Repeating decimals. When I say repeating decimals, I mean just that. Repeating decimals. Such as a decimal that has the repeating line. That's what you're looking for. You're looking for the repeating line. If it has that repeating line, then it's rational. Some decimals are called non-terminating decimals. It's a fancy way of saying they never end. They just go on, but there's not a pattern to it. If that's the case, it's not rational. We'll talk about that in a moment. Okay? Then, perfect squares. assume that by the time you get into 8th grade, you know what a whole number is. I would hope I would not have to break that down and talk anymore about a whole number. Okay? I'm going to assume that you know what a fraction is, that you know about repeating decimals, and hopefully perfect squares. Rational and irrational, that might be new vocabulary. Irrational numbers. The most famous irrational number has its own day even, and we will celebrate on that day. Pi. Pi day. The number pi. We usually stop it at 3.14, but it keeps going and going. There's no pattern to it. That's why it's hard to memorize. There's no pattern. It is just a random number. Now, I think there's like that Da Vinci Code type stuff. I think there's something with that number, but I'm not smart enough to figure that out, nor do I have time. So, irrational pi. Non-perfect squares. We talk about square roots, you're either going to have perfect, square root of 25 is 5, it's perfect. Square root of 31 is not perfect. If it is not a perfect square, it is irrational. And then, decimals that have no end. They're not repeating decimals. They don't have an end and they don't have a pattern. Rational, irrational. Now, the best thing I can tell you to do is to put that to memory. Rational, irrational. Now, this may be one that you don't know. Will y'all shut that window? I can't handle that hammering, hacking. I've never seen a roofing company not be able to finish a roof in a drought.
Got it.
Natural number. Sometimes they want you to like put them in categories. A natural number, like, well, what is a natural number? When I think of a natural number, the way I explain this is, when you see a little kid learning to count, every little kid counts how? How do they count? 1, 2, 3. Little kids don't know 0. No little kid starts at 0. Natural numbers are just your basic counting numbers. Little kids don't know fractions. Little kids don't know negative numbers. Little kids don't know decimals. So your natural numbers are just that, numbers that come naturally. And the progression of counting. 1, 2, 3. I've yet to hear a kid say, negative 1/2, 0. No, it doesn't work that way. Okay? So natural numbers. All right? So we got rational, we got irrational, we got natural numbers. The last one, just in case, integers. You will see that word a lot. Integers. Integers is a fancy way of saying positive and negative whole numbers. Positive and negative whole numbers. Integers is the numbers on your number line. Have a number line. Positive, negative, whole numbers. Okay? Rational, irrational, natural, integers. Categories. I'm going to keep going. Remember, I'm front loading this. I'm going to keep going. I'm going to turn the page. You may not have to, but I do. Square roots. I'm not going to spend a lot of time with square roots because there's not a lot that we're going to cover as far as 8th grade or even Math 1. Now once you get on up a little higher, they're going to throw in some other stuff. You can worry about that then. For 8th grade purposes, square roots, you're looking at two things. First, you're looking at perfect squares. Okay? And if no one's ever showed you this and you don't know this, because on your EOG calculator inactive, they're going to give you square roots, alright? And I still don't understand how kids can't do this, because if you can count, you can do this. Perfect squares, all you have to do is say 1 times 1 is 1. That's a perfect square. 2 times 2 is 4. That's a perfect square. 3 times 3 is 9. It's perfect. All I'm doing is counting. 1, 2, 3. 4 times 4, 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 91. 81. 10 times 10 is 100. So on and so forth, so on and so forth. Okay? So either you have perfect squares or not perfect squares. Okay? And then what you have to do is you have to take this and they say, okay, the square root of 4. Is that a rational or irrational number? Rational is a perfect square. Now we have two types of square roots. We have perfect squares. Then we have non-perfect. That's like us. We are not perfect. We try our best. We're not perfect. Now, I'm going to tell you the question they're going to ask. Non-perfect squares. They're going to, first of all, they're going to ask if it is rational or irrational. We know it is irrational. That is the first question they're going to ask. The second question they're going to ask. What two integers does that square root come between? This is two ways they word this on the EOG. First, they're going to give you something. They're going to say, is this rational or irrational? Then they're going to give you a square root and they're going to say, okay, what two integers does this come between? For example, the square root of 31. We'll get more in-depth with these type problems later on. The square root of 31 is not a perfect square. What is the perfect square that comes before 31?
30.
25. Which is 5. I'm going to make me a number line. What is the perfect square that comes after? 36. Which is 6. So the square root of 31 comes in between what? 5 and 6. If you can make this chart, you can answer these questions as well. All you're doing is finding the two that come between. Now, There are a couple complex problems that we'll get into, and you guys will enjoy working those out. Some of you won't. Most of you will, because you've really got to use your brain. Okay? So, we've got number system. We've got rational and irrational. We've got natural numbers. We've got integers. We've got square roots. Either you've got a perfect square, or you've got a non-perfect square, and you've got to tell if they're rational or irrational, or if you've got to tell where they come on the number line. Anybody confused yet? I would hope not. Okay? We're going to keep on going. I may like this. I can't do this with everything, but I can do this with this. Hold on, I just need to get my little paper here. Repeating fractions. I call them special fractions. I promise you that on the calculator inactive part of your EOG, you will have a funky square root problem that you'll be able to do. And you will have a repeating fraction problem that you will be able to do. Okay? There is a rule you need to follow. When you have a repeating decimal, a repeating decimal. First thing you're going to do is you're going to look for that repeating line. Okay, I've got a repeating line. Then I'm going to look for how many numbers is under that repeating line. How many is under there? One. If there's one number, I'm going to put 9 on the bottom. I'm going to put that particular number, whatever number that is, on top. And then we must always reduce. 3/9 reduces to 1/3. Okay? Look at this one. How many numbers do I have under my repeating line?
2.
So I'm going to put 99 on the bottom. Ah, there is a pattern. Math is all about patterns. What goes on top? Then, most of the time, if they're giving you one of these, you will be able to reduce. How do you reduce? 21 and 99 will both reduce by 3 are going to 21, 3 are going to 99. Okay. All you got to do is look for your repeating line. You've got it. Then you look. How many numbers are under your repeating line?
2.
Instead of saying numbers, I should say this. How many digits? How many digits are under your repeating sign? 2. 99 goes on the bottom. 11 goes on top. That'll reduce to what?
19.
I don't think they would ever take it past 3, but they may take it to 3. Follow the same rule. 3 numbers, 3 nines. And you can mark 2 of them out. 3/9 reduces again to 1/3. Got to know that pattern. 1 digit, 1 9. 2 digits, 2 nines. 3 digits, 3 nines. Anybody confused yet? Y'all still pretty good? Okay, let's recap. We talked about the number system. Categories: rational and irrational. Rationals are fractions, whole numbers, perfect squares, repeating decimals. Decimals that end, like 0.25 ends, that's rational. Okay? Irrational: pi, non-perfect squares, decimals that have no end. Natural numbers, like a little kid counting, 1, 2, 3. Integers, positive and negative whole numbers. Square roots, either they're perfect or they're not. There's only 2 questions they ask with those. 1, is it rational or irrational? 2, what integers does it come between? In other words, you just put it on a number line. Third thing we look at, repeating fractions, repeating decimals that turn into your little fraction. If there's 1 digit, that's a 9. 2 digits, 2 9s. 3 digits, 3 9s. It's just a little pattern. Okay? Anybody confused yet? Everybody good? All right. So, I would like for you to get your Chromebooks out.